Hello, welcome to another discussion on the types of motion. Please don't forget that oscillatory or vibratory motion is the second type of motion we have learned before. I remember I have taught you the one of the types of motion. I give you circular motion, oscillatory motion, random motion, and rotational motion, so on and so forth. I give you the different types of motion, and we also discuss on them. And this one is the second type of motion. We have discussed the circular motion. We did a lot of calculation. We spent time on that aspect of circular motion. Now, we want to now move forward and discuss this aspect, another aspect, which is a oscillatory or vibratory motion. Let us now look at oscillatory or vibratory motion. We want to look at a case of a simple pendulum. We want to look at a case of a simple pendulum. You can see now when you have a pendulum, what is the movement of that pendulum? It exhibits oscillatory or vibratory motion. Please don't forget, it exhibits oscillatory or vibratory motion. Now, what is oscillatory or vibratory motion? What is oscillatory or vibratory motion? Please don't forget that I have taught you this aspect before. Don't forget that I've taught you this aspect before. I told you that oscillatory motion is a motion of a body about its misposition. Example of such motion, I mentioned a child on a swing is pushed. The swing moves to and fro about its misposition. And also the pendulum of a clock. I also told you that it exhibits oscillatory motion as it moves to and fro about its mid position. I also gave you the one of a guitar, that the string of a guitar. The string of a guitar when strummed it means that it also exhibits oscillatory motion. Okay, now look at a case on the board. There is a diagram on the board. This one is a pendulum, a simple pendulum. What is the movement of this simple pendulum? It means that it exhibits oscillatory or vibratory motion. This simple pendulum as it moves, what happens? There are positions. You can see the position there. We have position 1, position 2, position 3, position 4, and position 5. It means that at position 1, there's energy we can take at this position. There's amount of energy we have obtained here, amount of energy. It means that the energy here is potential energy and it's always maximum. Please take note, it's always maximum and it's what? MGH. MGH, please don't forget. At this position, we have what? MGH. MGH, which is mass times acceleration due to gravity times the height. While at this position, we also have KE to be 0, meaning no kinetic energy at this position. It means it is 0. While at position 2, our PE, meaning the PE here is going to be the same as the KE. Please take note, it's going to be the same as KE. It means PE, potential energy, is equal kinetic energy. It means that MGH is equal half mv squared. That is what it means at this position. While at position 3, we have maximum kinetic energy. Maximum kinetic energy, please don't forget. It means that here is going to be half mv squared, half mv squared. Okay, it means that at this position also our PE here is equal 0. It means no potential energy. For the one of position 4 is simply the same as position 2, which is PE is equal KE. PE equal what? KE. Okay, at this position, don't forget that I said that MGH is equal half mv squared. Half mv squared. Okay. While for this number 5, at position 5, it means that here we have maximum PE. At this position, we have what? Maximum PE. And remember, I told you that this maximum PE is simply MGH. And our KE here is please take note. The KE here is the minimum kinetic energy. No kinetic energy. You can see when this pendulum when this simple pendulum moves, you can see the position when it swings. You can see the position when you move repeatedly. When you have a periodic movement, you can see the position. You can see the different position. You need that at this position, you can see the energy it will possess at this various position. And this one is likely exam question. Can have it as can have this one as a white question, or you can also have it as jam question. These are likely. This one is likely what examination question. Examination question. I think I've come across a question like this in the case of jam. In the case of jam, I've come across a question like this. Okay, I think we can stop at this position. We have looked at the pendulum. This one is the first case. Our next stage now will be the second stage. This one will lead us to time period of oscillation. This one will lead us to time period of oscillation. We want to look at how we can obtain the time period of oscillation. Okay? We want to see the one of time period of oscillation. And I will teach you the different also how to obtain that time period, how to derive the time period. Please don't forget, for the one of the time period of oscillation, for any small amplitude, the time period of oscillation remains the same. Please don't forget, that is the case we want to look at now. For the one of the time period of oscillation, for any small amplitude, the time period of oscillation remains the same. We want to see in that case now, I want to see that case of time period of oscillation. Okay, I think at this point I can say all the best.